screw with my mic a little bit again. I sound pretty quiet on my end. Make sure that we're all good. I think that should be better. Alright, so we are moving on to the next lesson, which is lesson number 8. Hey, how you doing, Ella? Let's see. Oh, there's a handful of you guys in here. Yeah, I don't know why it's so delayed on you guys showing up. It's showing that I only have 3 people in here, and then Ella was not one of them, so I'm assuming there's more in here. Oh well. I know you guys don't have it at the top of your page, but I wrote down the little formula that we discussed in Unit 11, Lesson 7. We talked about the A value, which was amplitude. We talked about the D value. Everything is so blurry. Oh, that ain't good. It's set for 720 right now. You might be able to change the video quality, Sierra. Right now, you have it at, it's set for 720p for the HD quality, but we have the option to make it less if we wanted to. Hopefully that might fix it. Alright, but back to what I was saying. Today we're going to focus on this letter right here, the letter B, which was on the inside of the parentheses. We're going to focus that on it today, and we're also going to focus on it tomorrow. So that B value is known specifically as frequency. You might just have to like do a refresh, Sierra. It should hopefully pop up. I don't know why it wouldn't. Yeah, I'm not sure why you wouldn't be able to see it. Especially because they gave us the option for you to change it to a lower quality if you need to. There's nothing else on my end that I can do to help you. But frequency is the B value. So that's the formula that we used yesterday. It's the same formula I took from lesson 7 on the front page right here. So it's that same formula, that A sine B theta plus C blah 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 blah. Same exact formula. I just rewrote it at the top because we're still using the same formula. We're just only focusing on that B value. Yeah, see if that will fix it for you, Sierra. So that B value is known as your frequency, and just like regular English, frequency, no, you don't have to memorize it. You don't have to memorize it. I'm just trying to explain what that number on the inside of the parenthesis means. That's all. The B value is frequency, and it says it's the number of cycles created from 0 to 2 pi, from 0 to 360 degrees. So a frequency is the number of curves you will see on one rotation, which doesn't really sound, it doesn't really seem like it will help explain until I start drawing the pictures. Sierra, I have no idea what to do to help you out. Maybe try connecting to Wi-Fi and then disconnecting Wi-Fi. Maybe try doing that and see if that will help. Otherwise, because it's something that's on your end. So frequency is the number of cycles. So it's how many curves that we're going to have. So I'm going to come down to the picture and I'll explain the frequency based off this specific graph so it will make more sense. So when you count frequency, when you count the number of cycles is just looking at the positive side. So since this is a cosine curve, so this has 3 cos x, what we're looking for is just looking at the positive side of the graph, we're looking to see how many cosine curves are over here. So if you look over at this thing, I told you guys there's a little trick with these graphs. A cosine curve creates a letter C, or something that looks like a C. So I'm asking, if you look at that positive side between 0 all the way over to 2 pi, how many C's do we have? And as you guys see, there's only one C. That represents your B value. That represents the number that's next to the x. Well, since there's only one C, that means the number in front of the x should be 1. So now I'm going to graph this next one, the 3 cos 2x. So I'm going to use the calculator to graph it. And I'm going to show you guys when we go to graph it over on this side, what's going to happen here is we're going to have 2 C's on the positive side. Okay? So it sounds a little confusing, but once I start drawing it out, it may make more sense. So I'm going to do it all with the calculator. I'm going to hit y equals, let me clear out what I have in there, and I'm going to type in the next one, which is 3 cos 2x. And I'm just going to go to my table. I'm going to delete off what I have in there. Remember, if you guys have numbers in there, you have to go into the table set and make sure that your calculator is on ask, not auto. So now that I'm on ask, I'm just going to start typing in these values, figure out what the answers are. I'll start off by doing negative 2 pi, and I get an answer of 3. So the answer was still 3 right here, so the number didn't change. Let me do a different color since I highlighted the other one blue. Now I'm going to type in negative 3 pi over 2, and I'm going to get an answer of negative 3. So notice that this graph did not touch the x-axis now. It jumped all the way down, unlike what we've been doing the last couple of days. The next one's going to be negative pi, and notice it jumps all the way back up to 3. So there's no middle dot on this one. It's changing just a little bit. And I'm going to tell you, if I type in negative pi over 2, it's going to jump down to negative 3, and then it's going to go all the way back up to positive 3. And this graph is just going to keep alternating between 3 and negative 3. So the graph is going to come all the way down. It's going to loop back up. And it's just going to continue this pattern forever and ever and ever. So we looked at the first function that was in black. And I know I might be going a little too fast, so I'll start to slow it down a little bit. But we looked at that black function, and we said that there was one C value on the positive side. Because we said frequency is the number of cycles between 0 and 2 pi. So on our graph, we are only focusing on that right half. So we're only focusing on the first and the fourth quadrant. So in this graph, if we look at the positive side, my goal is to try to count how many letter C's are on that right side. So if I go along this, if I follow this along, I have one C value right there. So as soon as I see a C value, I stop. And that's because it's a cosine curve. So we right now know we have one cosine curve. And then we see that it goes again, and we have a second cosine curve. So now I know that this was graphed correctly because there was a 2 next to the x value. This represents the number of cycles. So it's the number of cosine curves that we see. So because there was 2, that's why that 2 is there. Okay? So I'm just going to erase the highlighted part because I don't want to have it interfere for the next graph that we're going to do. So in part B, we're going to have 1/2. I'll use green this time. So because we're going to have 1/2, that means that the number of cycles is only going to be half of a C value. So let's graph it out so you guys can see what that's going to look like. So I'm going to delete everything that's in here on my calculator. I'm going to go back to y equals, but I'm going to change this so it's 1/2 x. Okay. So all I'm doing, typing in the new one, I'm going to go back to the table. I'm going to ask all those numbers again, just like we did, and we're going to figure out where they plot. So the first one's going to be at -2 pi. And as you guys can see, once again, oh, I'm sorry, this time it's at -3. Did I type it in right? Oh, okay. I guess it's down here. Was my last one -3 and I put it in as positive? I gotta check now. It's gonna bother me. No, it was +3. Okay. Never mind. I guess it's down at -3. We're doing it right. Or I was doing it right, I should say. Not 5, 2. Alright, sorry. So that first dot is actually starting down here at -3. Now when I go into type in the next one, I have -3 pi over 2. -3 pi over 2, please. Where did it go? -3 pi over 2. You guys are going to, oh, I did type in. I must have deleted the other one. It's going to come out to be -2.1213. That's kind of hard to graph, isn't it? So I know it's going to be somewhere like right about here. Because that's -2.1. But that's not a nice dot to graph. And there is a shortcut for doing this. I just wanted to go through the calculator with you guys first. Next one I'm going to have to type in is -pi. And remember, if you guys ever get the E on the calculator, that means that it's really at 0. Because our iPad calculators suck and it won't actually show the number 0. Then I have to type in -pi over 2. And it says that my number is going up to 2.12. So I'm going to be somewhere right about here. Now I'm going to type in 0 because I'm now at the axes, and that's going to be at 3. So on this negative side, that is what your curve is looking like. Notice that the letter C is nowhere to be found on that negative side, because when we started down here and worked our way up, it looks like it would be half of a C. It's not a whole C, it's only half of a C. So the way this graph is going to work, I could keep typing the next ones. I could do pi over 2, pi, 3 pi over 2, but the graph is going to start working its way back down because we can't go above 3. 3 is the highest point on this graph because that was our amplitude. Our amplitude was 3, so it can't get any bigger than that. So I know it's going to start going back down, and it's just going to be reflected on the other side. So there is a C value here. It's just the C value is taking up the entire graph. But when we're checking for frequencies, the frequency is only allowed to be between 0 and 2 pi. We're not allowed to look at this negative side. So if you look just at that positive side, we only have half of a C, which is what we were saying should have happened based on the frequency. So now it says, what did you notice happened to the graphs when we multiplied with 2 versus 1/2? So this is going back, and I told you guys there's kind of an easier way. Some of you guys may have recognized it algebraically versus the calculator, but it's going back to how we did transformations. So when we did transformations, when something happens to the inside of the parentheses, you guys may recall that we are really doing the reciprocal. Because what's actually happening is the graph, when we multiplied it by 2, notice the red graph got pushed together. The red graph is getting pushed together because it's happening more frequently. And that's why they use the word frequency. The green graph, when we multiplied it by 1/2, it gets elongated. It's getting stretched out. So when we go to do this mathematically, whatever's on the inside, do you guys recall that we have to do the opposite? We're really multiplying by the reciprocal. So I'm just going to write that down here. We're going to do some examples with that more tomorrow. Maybe we do a little bit today. Yeah, we're going to do a little bit today. Multiply by its reciprocal. Because when something happens on the inside of the parentheses, it's really going to be the opposite. Okay? So the other thing we got to talk about is period. So I'm going to go back up to the graph before I go down to exercise number 2. Now, the definition up top says period, since a sine or cosine curve repeats every 2 pi. So remember, we said that a normal curve will repeat every 0 to 2 pi from the positive all the way to the end. When we go to find the period, there's a formula. And this formula you don't have to memorize. It's going to be 2 pi over b. I'll give it to you guys on everything we do for the next week. But this 2 pi over b is represented by the period formula. So this will tell us the end of a cycle. So just think of when you're in English class, if you're talking about the period is the end of a sentence. When you're talking about the graph, the period is the end of a cycle. It's the end of a curve. So when I look at, let's say, the original black function, the c, I'll highlight it right in black and I'm going to follow it. If I create my letter C, notice that it ends here at 2 pi. So the period for that black function ended at 2 pi, so it is 2 pi. If I look at the red function, now I only want to create one C value. So if I create my C value, it stops right there. Notice when I stop right there, the period is at pi. So your period changes based on when the letter is created. Now, the green one, we can't actually find on our graph because I can't finish the C. I know it's going to be somewhere way over here because it's going to go back up, but I can't figure it out without the graph. So that's where the formula comes into play. Because as long as you know the frequency of a graph, you would be able to find where it ends. So that's what I'm going to show you guys down below. So in exercise number 2, it says for each function below, state the frequency and period. So the easiest part for these is to always find what the b value is. So the number out front, we don't even care about. We only care about this number that's on the inside. So that one's the easy one to find because it's just whatever number's in front of x or whatever number's in front of theta. So in this case, I'm just going to say b, and remember, b just means frequency. Again, I don't know why we don't just use the letter f, but I don't know. There's more math teachers out there that are smarter than me, I suppose. Frequency is the letter b, and in this case, b is equal to 1. If I look at letter B and I ask to find the frequency, I can just state B is equal to 2. And if I look at the last one, B is equal to 4. So as we go through to find the frequency, it's just picking the number out and you're done. That's the easy part. Okay? Now, when we go to do the period, that's where this formula comes into play. So the period represents the formula P equals 2 pi over B. So if you guys look at this first equation, we already know what the B value is, so I'm just going to plug it in. I'm going to have P is equal to 2 pi over 1. Because all I did was just take that 1 and substitute it in. And 2 pi divided by 1 is just 2 pi. So this is telling us if we were to graph it, one C value, one C curve would end at 2 pi. And that's what we just did in the graph above. That was the black graph that we just did up here. So if you guys look at this black graph, I went all the way through and then we said it ended at 2 pi. So now I just proved it to you guys algebraically. So now if I go to do this second one, the 3 cos 2x, that was the red curve that we did up top. So we're going to try to prove that it's going to end here at pi. So I'm going to do the same thing. Now I'm going to do the period formula. This time I'm plugging in the number 2. My iPad froze. Give it a second. There it is. All right, so we have 2 pi over 2 because once again, I just substituted that 2 into the bottom. And we can reduce that. 2 pi divided by 2, the 2's are just going to cancel out and we're left with pi. And again, that's exactly what we said it was on the graph. The last one, we couldn't find the answer, so now we can do it algebraically by doing the same exact process. I'm not even going to write down the letter B this time because you know you're substituting in that 4. And again, you're going to notice that it's going to reduce down because 2 pi over 4, the 2 and the 4 can cancel out and become pi over 2. Okay. So, I don't know if you guys have any questions with that. But that's pretty much all I want to do today. Tomorrow we'll go more into the algebraic ones, and I'm going to show you guys the trick for graphing it out by hand rather than using the calculator. Because as we saw, when we did that green one on the calculator, it got kind of ugly because the decimals were really ugly. So I'm going to show you guys a better way at graphing it, and you can do it all by hand. You don't even have to do any of it with the calculator if you don't want to. Okay? But tomorrow, that's what we'll work on, is more specifically with that. I mean, I don't know. Do you guys want me to do some more practice with frequency and period? Hopefully you were able to see what you were doing, Sierra. So today it's kind of the same, or this one is the same type of problem. I'm asking you guys to look and tell me what the frequency is. So you can just look at all those numbers. Once you figure out what the B values are, then you can plug them back into the period formula to figure out where the function would end. So again, this one would be 1. This is actually the same. Why am I writing this all down again? This is actually what we just did up top. This is the same thing as right here. The other two are different because they're fractions. So it's the same process. Let me know if you guys have any questions with that. I mean, essentially, that's how the homework is going to start off. A lot of the questions are just asking you, like for the first one, number 1, it says, determine the period. So you have to use the period formula, and you could solve everything in the first one. It's actually the same thing in the second one. Find the exact period. The only difference is in number 2, there's pi's involved. So just be careful when you're substituting them in. If you're not too sure about number 2, just wait till tomorrow, because I'm going to do that on the back page. 3 and 4, same thing, still talking about frequency and period. And then the back page, number 5, is going to be one of the graphing ones that I said I'm going to do tomorrow with you guys. So essentially, you could pretty much go through the entire front page of the homework tonight if you want to get a jump start on it. If you want to wait, you can wait. Okay? Sierra, did it fix for you at all, or did it just stay blurry the whole time? That stinks that it happened to you. But as far as everybody else, lesson's done. Go outside. It is beautiful outside. Enjoy yourselves. It should be nice today, but tomorrow they're calling for rain again. So enjoy what you can outside today. I'm going to go barbecue. I am going to go do some more outdoor stuff. I'm working in the backyard. Oh, sorry, Shannon. Just make sure you go back and watch the video. But, alright, well, I'm going to jump off. I will see you guys tomorrow. We'll finish up the back page of this lesson. And then, yeah, that's trig. Alright, see you guys.